Mixtures and solutions. So mixtures are a combination of two or more components that retain their identities. So you don't get a new substance, you just get two different things mixed together. So you have heterogeneous mixtures in which the parts can be easily recognized, something like a salad or like this sand over here. You have homogeneous or homogeneous mixtures in which the parts cannot be distinguished very easily or at all. So one thing is dissolved in something else, like salt dissolved in water or sugar dissolved in water. And we call these homogeneous mixtures solutions. Okay. Solutions can be liquid, gas, or solid. So some examples: seawater. You have water molecules, and there are many different ions that are dissolved in the seawater, surrounded by those water molecules. Air is a mixture of gases, mostly nitrogen and oxygen, but there's also carbon dioxide and water vapor and argon and neon and other gases. And then there's bronze, which is an alloy made from copper and tin, and this makes a solid solution. Now, acids. Many reactions on Earth involve acids and bases, so acids and bases are kind of opposites of each other. So an acid is a solution containing a substance that produces hydrogen ions in water. Hydrogen ions is an H+, which is really just a proton. This is our hydrogen atom over here. We have a proton and an electron. If we have an H+, that means we've lost this electron. So we've lost this electron here, so what we're left with is that single proton. Now some examples here: hydrochloric acid, sulfuric acid. When these are put in water, they break down. Like hydrogen chloride will break down into hydrogen ions and chloride ions if I put it in water. Now, acids are measured on something called the pH scale. And the pH scale is based on the concentration of hydrogen ions. So the equations for that, you have pH is actually the negative log of the concentration of hydrogen ions. It's a little complicated for what we're doing, but just know there is a way to calculate this. And it is based on the concentration of hydrogen ions. So pH of 7 is neutral, which this would be pure water. Okay, is neutral. pH less than 7, so basically 1 through 6, is going to be acidic. And a pH greater than 7 is basic, so really 8 through 14. So the scale runs from 1 to 14. So some examples on the pH scale. So pH of 2 is lemons, pH of 4 is tomatoes, milk has a pH of around 6, distilled water like pure water has a pH of 7, so it's neutral, antacids a pH of about 10, household ammonia pH of 11, and then like drain cleaner is a pH of 13. So more acidic as you go closer to 0. So more acidic this way, the lower the number, the more acidic. The higher the number, the more basic. And as an example, we have carbonic acid. So carbonic acid, or H2CO3, is the most common acid on Earth. It's very common in rainwater. In fact, all rainwater is slightly acidic because of carbonic acid. So what happens here? The water, H2O, in rain combines with carbon dioxide in the atmosphere, and you get your carbonic acid. And then that carbonic acid breaks down and produces hydrogen ions and a bicarbonate ion. So this is where your hydrogen ions are coming from. So this gives rainwater a pH of around 5 to 5.6 naturally. So pure natural rainwater in a natural environment should have a pH of around 5 to 5.6. Now this is enough to slowly dissolve limestone to form caves. So one of the ways that limestone caves are formed is the limestone, which is calcium carbonate, is dissolved by the acid or the hydrogen ions in our carbonic acid. So the carbonic acid reacts with the calcium carbonate and actually will start to dissolve it. This takes thousands of years for enough carbonic acid mixed with groundwater to dissolve limestone to form caves. So it takes a long time for this to happen, but it does happen slowly over time. Now, something else that happens before the water gets in the caves and starts dissolving limestone is, other than the carbonic acid, it also picks up organic acids from the soil too. So it gets slightly more acidic than this 5 to 5.6 because it does pick up some organic acids from the soil as it kind of leaches through the soil. This is just kind of a diagram showing what's going on here. So we have our carbon dioxide, we have our water molecule. These combine and you get your carbonic acid molecule here. Now bases, I said acids and bases are opposites. So a base is a substance that produces hydroxide ions in water. If you notice, hydrogen ions from our acids react with our hydroxide ions from the water or from the bases and produce water. Okay, so bases neutralize acids. So the hydrogen ions react with the hydroxide ions to produce water. So when you have a neutralization reaction, what you end up with is your acid and base react, and you get water from that. And usually a salt of some sort. So like, for example, if I have hydrochloric acid and I add that to sodium hydroxide, okay, I get water and I get sodium chloride from that. So I get salt water. So this is a very, very strong acid. This is a very strong base. I mix these together and I basically get salt water. So pH greater than 7 are bases, have a pH greater than 7. Now, many household cleaners are very basic, so around a pH of 11 to 13. Sodium hydroxide, which is our example from up here, solutions have a pH of around 14. So these are some of the strongest bases we can have, are sodium hydroxide.